Good morning. Myself Dr. Gangadhar H. Hugar, Senior Lecturer in Chemistry, Applied Science Department, Chandigarh College of Engineering and Technology, Diploma Section Sector 26 UT Chandigarh. I am before you to talk on corrosion preventive measures by external preventive measures 2. In the previous lecture, we discussed about what is corrosion, what are the different types of corrosion, what are the mechanism of corrosion and what are the disadvantages of corrosion and how corrosion can be prevented by internal corrosion preventive measures. And today's lecture is focused on corrosion preventive measures which can be adopted after the manufacturing of a metal or a metal alloy. That means, the corrosion has to be prevented by external measures. So, to recapitulate few things, what are the importance of corrosion prevention? Why we should think about the corrosion prevention? We also came across that the corrosion can be described as weeping of metals. What happens when metal begins to weep? Is this lead to disasters? Yes. For example, we have a Bhopal tragedy. If we see the history of worst chemical disasters in industries, the first that comes to our memory is one of great Bhopal tragedy, which happened on the night of December 2nd and 3rd, 1984. The cause of this accident is not clear, but it could be very well be due to corrosion, and if such is the case, it may well go down as the biggest fatal accident due to the corrosion ever recorded in the history of corrosion accidents. The another infamous example of corrosion fatigue occurred in 4 years later, 1988, on the airline flying between the Hawaiian island. This disaster, which cost one life, prompted the airline to look at their airplane and inspect for corrosion fatigues. So, what lesson we learned from the Bhopal tragedy? Corrosion can be disastrous, but is not necessarily a cause. Thus, to prevent any disasters by corrosion, follow all the measures for preventing corrosion, since prevention is better than cure. Keep all the safety related equipments in order. Properly manage safety related equipments regularly. Keep residential area away from the plant as far as possible when we are talking about industrial accidents like Bhopal tragedy. So, today's lecture is entirely focused on the part which we call it as protective coatings by metallic coatings, non-metallic coatings. So, in the previous lecture you must have studied about the prevention of corrosion by metal coatings. Today, we will just see some of the advantages and disadvantages of metallic coating, and today we are going to discuss in detail about non-metallic coatings. So, what are the corrosion preventive methods? You have seen in the last lecture, there are 5 of them. One is modification of the environment, second modification of metal or material properties, which we call it as internal corrosion preventive measures. Third one is use of protective coatings. It may be a metallic coating or non-metallic coating. And fourth, cathodic or electrochemical protection. Then fifth, corrosion prevention by material selection and design. So, today's lecture we emphasize on metal coatings and their disadvantages to the some extent, but more focus will be on non-metallic coatings. Is that right? So, use of protective coatings, either it will be metallic coating or non-metallic coating. So, let us have some terminology which commonly used when we study the corrosion prevention, particularly by the use of either metallic or non-metallic coatings. So, the metal surface may be coated with metallic or non-metallic or organic material coatings for protection against the corrosion. Suppose, if this is my metal which I want to protect, the metal which is to be protected is called base metal. This is base metal, right. The metal used for coating is called protecting metal. So, suppose if I apply another coating of another metal on this, then that is called coating metal. Okay. So, this is protecting metal and this is my base metal. Let us take example, iron is coated with zinc metal. In this case, iron is a base metal and zinc is protecting metal, and such iron or steel is called galvanized steel, depending upon the way by which you have applied this protecting coating. Okay. In this case, it is metal we are using. So, coatings on base metals, what are the metals, what are the merits of the metal which we use for coating purpose? As I told you in the previous slides, see, if I want to protect iron by zinc metal, then zinc is called protecting metal. What are the qualities or the merits of the metal which we need to look at when we want to coat a base metal by another protective metal? It is a relative reactivity to the base metal, number 1. What is that? It is relative reactivity to the base metal and ability to form a self protecting layer. So, it must form its own oxide layer or any other layer which can itself protect from the corrosion. For example, zinc, nickel, tin, cadmium and chromium etc., you must be knowing that they are self protecting metal. Naturally, we call it as the what passive metals. Is that right? If the protecting metals is less anodic, if the protecting metals is less anodic to the base metal, then protective coating of such metal on the surface of the base metal is described as cathodic protection. Cathodic protection, right. Suppose that the cathodic protection was employed before electrochemical theory or electrochemistry had been developed by Humphrey Davy. As early as 1824, he provided British naval ship by cathodic protection. It is quite old technology. So, on the other hand, if the protecting metal is more anodic, that means Take the example of the previous example what we studied. Look at this galvanized steel. Here zinc is more reactive than iron. So, therefore, on the other hand, if the protecting metal is more anodic to the base metal, then protective coating of such metal on the surface of the base metal is described as anodic protection. So, anode is one which can undergo oxidation. So, in preference to the base metal, if the protective metal is more oxidizing in nature, oxidizing itself, then we can call that protection layer is as the anodic protection. Anodic protection is a recently developed technology which we will discuss in the comparison of cathodic anodic protections. So, where do you find this type of protections? So, we will find lot of such protection is provided to the components of automobiles, household appliances, fixtures, silverwares, galvanized steels, tin cans, etc. So, there are two types, one is cathodic and another one is anodic protection. So, let us see the comparison, and this is what I wanted to emphasize. The utilization of cathodic protection is restricted to moderately corrosive condition. What does it mean? If the condition of corrosion, that is the metal being exposed to, then that condition, if it is a moderate one, then we can have cathodic protection. However, anodic protection can be used where it can be used in aggressive conditions, from weak to aggressive conditions. So, the installation of a cathodic protection system is relatively inexpensive. It is not expensive as compared to the installation of anodic protection system. Therefore, this is having advantage. And one more important point you are supposed to remember about this cathodic protection is, this protection must be applied in such manner that it must be a continuous, strong, non-porous layer. I repeat, this protection must be continuous, strong, non-porous in nature, so that it will not felicitate the formation of galvanic cell. If it tends to form a galvanic cell, then more corrosion is expected. However, in case of anodic protection, even if crack appears on the on the protected material, so does not matter, because the base metal is having cathodic nature in preference to the protecting metal. Therefore, in protecting the base metal, the protecting metal will be getting oxidized in preference to the base metal. So, as a result it will protect. So, therefore, this is one of the important advantage of anodic protection. So, as you see here, it is inexpensive cathodic protection and anodic protection is relatively expensive. So, what are the other methods by means we can control the corrosion? So, there is a answer. Here is an answer that non-metallic coatings, that is chief function of a metallic or non-metallic, whichever we coat, they should provide a satisfactory barrier between the base metal and its environment. Wherever we are using that metal, it should resist that environment, so that it will not undergo corrosion. So, that is the main purpose of either metallic or non-metallic coatings. So, non-metallic coatings are materials which are produced chemically or electrochemically on the base metals. So, we have to develop such coating of a material which can be developed either by chemically or electrochemical on the base metal. Such material must be less reactive and more corrosion resistant compounds. Okay. When we protect a base metal, then it must have what? it must have a less reactivity and should have more corrosion resistance. Non-metallic coating may be consisting of either it will be inorganic or organic materials. So, this is we are going to discuss in detail today. So, let us see inorganic coatings. Inorganic coatings. So, inorganic coatings may be surface conversion coating or chemical conversion coating. So, these protecting coatings have a dual role to play. What are those? Number 1, coatings protects base metal from corrosion. This is the first primary objective of inorganic coating. Secondly, provides a surface ideal for painting or other decorative protective measures what we can cover up. So, these are the two objectives with which we intend to coat a base metal with inorganic coatings, and these type of coatings are generally provided to iron, steel, aluminum and its alloys, and zinc and its alloys. Normally, these are the alloys of iron, aluminum and zinc, and their respective metals can be coated with inorganic coatings, so as to make these metals and the alloys fit for corrosion resistance in any environment. So, inorganic coatings, the by chemical conversion, coatings are generally produced on the base metal by immersing in a solution of suitable chemical reagent, which reacts with a metal surface and develops an adherent coating. These coatings may be a phosphate coating, it can be a sulphide coating, it can be a selenium coating, it can be a oxide coating, it can be a chromate coating, anodized coating, ceramic coatings or slushing compounds can be used. All these, the name themselves are suggesting, look at that, phosphate coating, that is inorganic compound, sulphides, metal sulphides generally, selenium coating and selenates. So, oxides, as oxides of that particular metal which can be coated as a protective layer there, chromate, anodized ceramics. So, we will discuss these are the things from the point of view of examination. These points are very important even for diploma as well as degree students. Okay. Wherever you are studying the corrosion chapter, and these inorganic coatings by these methods are generally are of great importance. So, now let us take the first one, that is phosphate coating. What do you mean by phosphate coating? Let us take one particular example. So, when iron base metal is dipped in a phosphating solution, what do you mean by phosphating solution? Phosphating solution means a solution of phosphoric acid H3PO4, phosphoric acid, and a primary zinc or zinc primary phosphate sudden into bracket H2PO4 twice. The following reactions takes place to develop phosphate coating. See, as you can see in the film here, this is called a body in white. When a automobile is being produced, this has to be protected, and generally the inorganic coating, primary coating what we call, it is taking a dip in the phosphate solution. This is a made to dip in the phosphate solution. What that phosphate solution contain? Phosphate solution contain phosphoric acid and zinc primary phosphate solution. This is the solution in which this BIW means body in white is being dipped before it is being painted. So, this is surface preparation. Okay. So, here the body which is mainly steel or iron. So, this will react with phosphoric acid and it produces a primary iron phosphate, liberation of hydrogen takes place there. So, then you have taken the solution primary zinc phosphate as well, therefore, it undergo hydrolysis to yield tertiary zinc phosphate along with the production of phosphoric acid. So, in successive reactions primary iron phosphate converts into secondary iron phosphate, secondary iron phosphates change into tertiary iron phosphate, and all these things the phosphoric acid is produced. So, these three reactions will be affected, will be enhanced because the metallic iron will react with it, shift this equilibrium in the right direction, forward direction. So, therefore, finally, secondary iron phosphate, that is FeHPO4 and tertiary zinc phosphate coating are produced. Look at this, this is the tertiary phosphate hydrated and then secondary iron phosphate are going to produced as a coating with the liberation of hydrogen and phosphoric acid. So, this reaction is retarded by the production of hydrogen, however, that can be enhanced by the use of a oxidizing agent like sodium nitrite etc. Therefore, phosphate coatings can be formed on other metals like zinc, cadmium, aluminum and tin. Is that clear? So, this is inorganic coating, that is phosphate coating by dipping the material in phosphating solution. Okay. You should remember this very well, and these are the reactions. These are elementary reactions and these equilibriums are being shifted by the reaction of iron with phosphoric acid. Is it right? So, this is about the phosphate coating. I have an video clip which is this I am going to skip now, and here in this video we can see that there is a coating is being done by phosphate coating before this type of painting is to be applied on the BIM, body in white. Okay. Next, we will go to the next. The second is sulphide coating, as we have seen in the previous section. Look at this: phosphate coating, sulphide coatings and selenium coatings. We will be studying now the what is known as sulphide coating. So, base metal on which phosphate or oxide protective film is not easily formed, whenever the case when the metals oxides are not easily adhering or phosphate film is not adhering. So, therefore, such base metals can be provided with the sulphide coatings and which is quite effective for a short period. Remember, it is only for a short period, since this coating is undergoing oxidation and therefore, it is short lasting. Therefore, sulphide coatings are generally short lasting, because it will be getting oxidized due to the plenty of oxygen available to them, and as a result that will be get converted into phosphate, which may be leached out whenever the whenever water comes. So, therefore, we will be having short. Next, come to the selenium coating. Okay. Selenium coating. So, oxides and sulphide coatings are stable only at a low temperature. Remember, the oxide and sulphide coatings what we talked, they are we are going to talk about oxide coating little later. However, we have talked about sulphide coatings in this. So, these are effective only at low temperature and becomes ineffective at high temperature, hence selenium coatings are developed. Okay. So, it is developed by dipping base metal in selenous acid H2SeO3 of acidified solution of sodium selenate. Sodium selenate is salt of selenic acid, this hydrated, and you acidify this with selenous acid, then we get a solution in which the base metal is to be dipped for a specified time, so that it can develop its selenium oxide, selenium coating, right. Where do you find this type of coatings? The selenium coatings are provided on the components of aircraft and high speed automobiles, say aircraft and high speed automobile, jet aeroplane components, see light compacting aircraft, so which are being produced in HAL, Bangalore and all these things, they are normally coated with the selenium coatings. Okay. So, this is about selenium coatings. Now, let us move on to the next inorganic coating. What is the next inorganic coating? Let us see, that is oxide coating. All of you heard about it. All that is oxide coatings. Oxide coatings can be formed on the surface of a metal like iron, zinc, aluminum, tin, chromium and nickel, etc. The oxide coatings normally produced by dipping base metal in concentrated sulfuric acid. As you know, concentrated sulfuric acid is HNO3, which is an acid as well as the oxidizing agent. So, therefore, if when a metal is dipped in this nitric acid, it develops its own oxide layer and that is insoluble in nitric acid. Normally what happens, metallic oxides are alkaline in nature. So, what happens when the oxide is produced on exposing to the acid or acidic atmosphere, they generally dissolve, but here these metals produce such an oxide layer which will be adhered to the surface of the metal quite strongly and therefore, further reaction with nitric acid or any acidic atmosphere becomes less. So, as a result they provide corrosion resistance capacity to these metals. So, therefore, such a tendency to protect a metal by itself developing an oxide layer, we call it as passivity. So, example of passivity you must have heard about it, that aluminum metal is due to the formation of its oxide film on its surface, which provides a protection to aluminum from further corrosion. But for better protection, a layer thickness is increased. So, if we on exposing the metal to the air itself, it develops oxide layer, but if you provide the aluminum with a thickness which must be 100 to 1000 times greater than what it can develop. So, electrolytical method or electrolytic oxidation method, or it is also called as anodizing method, then it will protect, it will have a higher protection capacity. As a result, we can increase its corrosion resistance capacity and the life of the layer will be enhanced considerably. So, you must have recollect, you must have be studied the Filling-Bedworth rule here. Okay. Filling-Bedworth rule for chemical corrosion, what it says. Now, there will be a question, explain Filling-Bedworth rule for chemical corrosion. It is state that I will take up that one here. So, let us take the some other definitions which are related to understanding of Filling-Bedworth rule. It is a qualitative rule. The ratio of volume of metal oxide formed as corrosion product to the volume of metal is called a specific volume ratio. Specific volume ratio, volume of metal oxide to the volume of the metal, this ratio is called, what is called as specific volume ratio. This is very important. Smaller the specific volume ratio, greater is the oxidation corrosion. Means if the specific volume ratio of the metal becomes less greater, then greater is the oxidation corrosion, if provided the specific volume ratio is smaller. See, when it will be smaller, when the volume of the metal is greater than volume of the metal oxide formed. So, therefore,
it is having a porous nature. Since oxide film what will be developed on the metal will be a porous one. It has a what is known as pores, holes, small holes. So, therefore, through which the oxygen can diffuse and cause further corrosion. Okay. So, for example, specific volume ratio of for tungsten, if you see chromium and nickel,